In the last lecture, we saw that how these neural networks are, and multi-layer neural networks are in fact shown or classified, or you can say mathematically formulated, how the weights and the layers are defined. In this lecture, we have seen, but I'll just repeat for the sake of completion that in the neural network development are being made generally in two phases. Normally, we have been talking, or most of the time, we talk about the training phase, okay, in which you have inputs and output, and you have a problem, and you are actually training the network so that you can build a network with its weights which will be used. So that is the first phase, that is the training phase. Then the second one is the recall phase, in which you use the neural network for the problem which you have designed this network for. So these are the two basic phases in which neural network actually works. So this we have already seen, and there are certain subtle things in it that you may have training and testing phases in one, and then you design the neural network. Now in this class we'll see different kinds of processing in which we use neural network. Okay, so if you see here, the first type of processing which neural network is used for is in fact what you call is auto association. What do we mean by auto association here? Auto association is something the network actually stores various objects. I'm showing the things that will be normally in data form. These objects will be in data form, but I'm showing it in an image format. So normally the network is supposed to store certain objects in its weights, or whatever you call, or in its mind, and that is this storage is done while training. And while training, we also train it with noisy counterparts of input. Here input and output are in fact same, okay. So if you give a set of input, same also serves as output. Then what is the difference? If you know the input, then why should there be a neural network? We train the neural network for recognizing that input in a noisy environment. So there are several cases in which the inputs are to be first processed, so that the noisy part of the input, or the input, is classified in terms of no noise inputs, okay. So that kind of learning is auto association. If you see in this figure, these are the actually 4 objects, or maybe n objects, which will be stored in the network. And what I am doing here is, in a recall phase, I am giving this, which is incomplete, not matching to any of these objects. But since this neural network has been trained for this kind of situation, in which these are the possible outcomes, and when you give a noisy input, it classifies exactly as what could be the possible non-noisy object could be. So that is what we say that neural network is doing auto association, or you can say noise filtering, you may say, in different depending on the application, or the name of application which we come across. So this is in a nutshell one type of processing which neural networks are used for. The second type of processing is the hetero processing. It is similar to auto association, but hetero association is something like we associate this data with this data, this data with this data, and so on. And then when we supply, suppose this again noisy data, it is able to classify it as corresponding data. So here, if you see this square, it has learned to be associated with this, what you call trapezoid, or whatever the shape may be. And when you give a noisy input, maybe like this, and you want to know that to which it matches, which association it has, and it gives you a correct result, okay. So that is the second type of processing which we normally come across in neural network. Then there is another kind of classification another kind of learning which is popularly called classification. In this kind of learning, what we do is we classify the data. So it is not like recognizing one data to mapping one data to another, but we are trying to classify given data into a particular class. Okay, so for example, this class could be noisy also. For example, if you have 4 class of data over here, so if I give something like this, okay, this is not there. So sorry, and you know how this shape is being made here. So suppose I give this kind of data, which is you can say trapezoid, and this also matches with this because it has 4 sides, but it also matches with this because it has straight sides and slanted one. So we don't know what the classification could be for this, but it would classify that. So that is how we use the neural network for another kind of processing, that is called classification. So the objects are to be classified into a given set of classes. Okay, so the classes are known and you classify a given object, maybe noisy or non-noisy, whatever it may be. Then you have another kind of network processing, neural network processing, which we call recognition. It is again very much similar to classification only, but here if you see, the data is noisy also, and you have to classify into this. So if this triangle and this are supposed to be similar, whatever is the class of triangle, that should appear over here. So that is a slight difference, but it is almost similar to classification. Here the classifications are in fact something like different from slightly different from classification. So it recognizes that it is similar to triangle, even though it is noisy, one side is missing. So that is how that is for which this network has to be trained. So that is another kind of problem which neural networks normally solve. This is one of the important another kind of learning learning requirement from a neural network, that is generalization. So here if you see this, you have a given data, and for this given data you want to train the network for x and y. So the same kind of series is mimicked. So whatever is the time series data given, the other neural network mimics that. So it generalizes the given situation. So for input it has to match this. So suppose for example I have matched this, and this is neural network and this is the actual happening, and after this I want to know what will happen, because I don't know in future what it is going to give, but I have trained the network say up to a good level, and now I can give a certain input. So for example this time, and it will say give you some kind of projection in the future. And you, if your network is, you're lucky and your network is good, and if this is a stock price, then you can definitely have some fortune. And if it is bad, not trained properly, or not a good network, or some data problem is there, then you may also that may be a pitfall of using a neural network. Okay, then let's move to next slide. So here we have already seen what do we mean by learning. Basically, learning and adaptation means how the trying to train the weights for a certain problem. Okay, that is what we mean learning. What learning is. I have already done this in maybe in earlier class. So that is what it is. That means you train the weights and say that it is giving me the same results, and that is what learning means. Now there are basically two major learning paradigms in neural networks which we come across. One is called supervised learning. Okay, so what do we mean by supervised learning? If you see here in the supervised learning, the example of supervised learning which we have already seen is feed forward back propagation neural network. Okay, so in that, if you remember, we had input, we will have input in this case, and corresponding to that there were set of outputs. These two data were given to us, and basically it was mapping from input space to output space. So in supervised learning, this is what supervised learning is used in this case. What we do is we have the output, that is the desired output for which the mapping is required, and this is the actual output of the neural network, and that is what is to be mapped to this one. But we already know what should be the output, what is the desired output. So what we do in this kind of learning, what we have is we see the output of the neural network for input, and we see what is the desired. Then some kind of distance generator is there, that is error. Normally you can say a kind of error is there, and that error is calculated, and that error makes a kind of signal which is called correction signal, and that is passed to the neural network, and this process is done again and again. So this is here in this case we assume that there is a input, there is a output, and there is a teacher who is supervising this process to make this network make this network to perform according to the required specification. So here a supervisor or a person is there who is seeing that network is performing to the desired output and input mapping. So this kind of learning is so-called supervised learning, because here input and output are both there. There is another kind of learning paradigm which is also very interesting and quite useful at times. In this case, what we see is we have only an input, no output is there, and this kind of network comes very easily when very much in the cases where we want to discover some patterns of similarity or patterns of dissimilarity among the input data itself. There is nothing like classified inputs, nothing like classification, or we don't know anything about data, but we have a stream of data coming in, and are these data related to each other, are these data have similarities among themselves or not. So that kind of discovery is possible in this kind of paradigm, that which is in which you don't have any output as such, you have only input, and you want to get some knowledge from the input itself. Human beings are very good at it. Okay, for example, if you go to some place, and again if you go to some place, then you immediately come to know that yeah, this place I have already come, or maybe this place is very much similar to the other place, something like that. So that kind of a learning is called unsupervised. Here you don't have any supervisor or any desired output which actually helps you in training this. In fact, here you have to just take the input, and whatever that generates, according to that output you have to make certain training. So this is very interesting kind of this, and it actually helps you in discovering different knowledge from a data, where so this kind of learning is quite interesting in that way. So we'll just come across some learning rules. I think I'll stop here. Learning rules will take up in the next set of slides.